Right, so today's crash course is on qualitative analysis. Our agenda today is to go through the test for cations. Then there will be MCQ and structured question for you to try. Then the test for anions, and then again there will be questions and test for gases. Okay, so just three things: test for cations, test for anions, and test for gases. So even though it's just three things, right, the question can test you two of those or all three, and can even bring other topics in as well, especially for this chapter. Okay, so we have to really master this chapter in order to do well lah. Right, then there'll be extra practice questions. So if we have time at the end, right, I'll go through these extra practice questions. If we don't have time, I'll just go into the Kahoot quiz and everything else. Okay, so without further ado, let's begin. Okay, so in qualitative analysis, there are three things that we have to test: cations, anions, and gases. Okay, these three things. We'll start with cations. Okay, so there are in total 7 cations that you have to test. Okay, 7 cations: aluminium, zinc, iron 2, iron 3, ammonium, calcium, and copper. Okay, so later I'll give you a few memory shortcuts to remember all the observations for these ions. Okay, so there are 2 reagents that we use to test for these cations. One is sodium hydroxide solution, your NaOH. The other one is aqueous ammonia, okay, NH3. That means, right, these reagents, you will add them to your solution containing your cation. Okay, this is your solution containing the cation. You either add sodium hydroxide or aqueous ammonia, and you'll see some observations. So there's 2 observations that you have to see. First is when you add a few drops. Okay, when you add a few drops of sodium hydroxide or aqueous ammonia, you first identify the color of the precipitate form. Okay, so if there's a precipitate form, you need to identify that color. That is your first observation. So white, green, blue, those are what you want to look out for, those colors. And then your step 2 is to add excess. That means you add more than a few drops. Okay, and the purpose of adding excess is to see the solubility of the precipitate, right? So you want to see whether it dissolves in excess sodium hydroxide or whether it dissolves in excess aqueous ammonia. Okay, so we'll just get started with testing of cations with sodium hydroxide. Okay, so there are 2 things. One is sodium hydroxide, one is aqueous ammonia. Right. So for sodium hydroxide, right, again, there are always 2 observations that we want to find. First is the color of precipitate. Okay, we want to look for the color of precipitate. Then second, we want to look of the solubility in excess. Okay, first is color of precipitate, second is solubility in excess. So I have a few memory shortcuts for remembering the color. Firstly, Z will be white. Okay, so Z will be your white precipitate. Z stands for zinc, A is aluminium, and C is calcium. Right, so when you're testing for your zinc ions, aluminum ions, and calcium ions, there will be a white precipitate form. Okay, when you add a few drops of sodium hydroxide, there will be a white precipitate form. And one important thing to note, right? All your precipitates, they are hydroxides. Okay, so if you are testing for calcium, the precipitate form will be calcium hydroxide. Then if you are testing for zinc, the precipitate will be zinc hydroxide. If you are testing for iron 2, the precipitate will be iron 2 hydroxide. Okay. So these are the, sorry, is this PDF shared with us? Yeah, I shared this PDF with you in the WhatsApp. So I send it to everyone who registered. Is the resources in the WhatsApp. Okay. So Z will be your white precipitate. That is for the color. Okay. Then let me tell you a short story for the other memory shortcut. So there was one time, right, my family was trying to plan for a picnic. Okay, then we were unsure whether to drive there or not because the parking fees were quite expensive for just going to the park for a picnic. So we decided, what about we forget about car and we just ride bicycles? Right? Riding bicycles is more eco-friendly and it's also a good exercise. So the memory shortcut is forget family car, go ride bicycles. Okay, forget family car, go ride bicycles. So you have your first three letters. Okay, actually I should write it. I should write it here. More space. Okay, your first three letters FFC. Those will be the three ions. Iron 2 plus, iron 3 plus, and copper 2 plus. Okay, then go ride bicycles. G will be green. R will be reddish brown. And C, Cu2 plus, sorry, and B will be blue. Okay, so forget family car, go ride bicycles. Fe2 plus will be green in color for the precipitate. Fe3 plus will be reddish brown precipitate. And Cu2 plus will be blue precipitate. Okay, so you just need to remember these two, ZEC and forget family car, go ride bicycles. Once you remember these two, then you will never forget the colors of the precipitate. Okay, so I just repeat. For ZEC, you have zinc, aluminium, and calcium. Okay, all these three you will have white precipitates. Okay, as you can see, white precipitates form. So you have zinc hydroxide, aluminium hydroxide, and calcium hydroxide. Then the second memory shortcut, forget family car. Okay, Fe2 plus, Fe3 plus, Cu2 plus. Go ride bicycles. So go will be green, ride will be reddish brown, and bicycles will be blue. Okay, so green, reddish brown, blue. And for ammonium, there will be no precipitate form. So because this, we actually learned this before, right? NaOH is your alkali. Then ammonium compound. Your alkali plus ammonium compound is actually a reaction we have learned in the topic acids and bases. Okay, so it's your base or alkali reacts with your ammonium salt to form salt water and ammonia. Okay, so there is no precipitate form, but there will be ammonia form. Okay, that's all you need to know. Right? So you just remember these two and you'll know the colors of the precipitate. Then after knowing the colors, we have to find the solubility in excess. Right? This is the second observation. So what happens if you add excess sodium hydroxide solution? Only two of these ions will be soluble. Okay, so instead of Z, it will be just Za. Okay, so zinc and aluminium. These will be your soluble in excess. Okay, that means zinc hydroxide will dissolve in excess sodium hydroxide to form a colorless solution. Okay, sorry, hold on. You couldn't open the file. Okay, give me 1 second. Let me check the file, whether it's shared. Should be able to open. I allow everyone to open already. I'll just send you the link over here. See if you can access it. Okay, then I'll continue going through. So for zinc hydroxide, it will dissolve in excess sodium hydroxide to form a colorless solution. And same for aluminium. It will dissolve in excess to form a colorless solution. Okay, these two are the only soluble ones in excess. That means the rest, right, it will remain in excess, or you can say it will be insoluble in excess. Okay, remain. See, the rest is all remain. That means they are insoluble in excess sodium hydroxide. Okay, and the reason why zinc and aluminium hydroxide, right, they are soluble in excess If you remember, right, it's because they are your amphoteric oxides. Okay, so they can react with both acids or bases. Okay, and sodium hydroxide is a base slash alkali, so it can react with it, so it will dissolve inside it. Okay, so three things to remember. Z will be white in color, and then forget family, car, go ride bicycles. That will be your other three colors. And finally, for solubility, only Za will be soluble, zinc and aluminium hydroxide. Okay. All right. Okay, nice. Managed to open. Okay, then now we move on to the test for cations with aqueous ammonia. All right, aqueous ammonia. So there's actually not much of a difference actually. So I would say there's only two differences. So it's similar to adding sodium hydroxide, except two differences. Okay. The first difference is no precipitation with calcium. Okay, so previously, right, when you add sodium hydroxide to calcium ion, there will be a white precipitate form. But for aqueous ammonia, if you add aqueous ammonia to calcium ion, there will be no precipitation. Okay, so that's the first difference. The second difference is the solubility. So instead of Za soluble, it will be Zc. Zinc and copper. So your zinc hydroxide will dissolve in excess ammonia, aqueous ammonia, to form a colorless solution. All right. Then your copper, your blue precipitate, copper 2 hydroxide, it will dissolve in excess to form a dark blue solution. Okay. So this time when you add aqueous ammonia, these are the two that dissolve in excess to give a solution. Then the rest, as usual, will be insoluble. Okay, so it's similar to adding NaOH except for these two differences. Right, so that is how I remember the test for cations. Are there any questions so far? Okay. If not, can I have you guys to try question 1 and 2? So these two questions, question 1 and 2, will give your 7 minutes. All right, we'll be going through question 1 now. The following observations were made by separately reacting 3 solutions containing metal ions. Okay, so metal ions, we know that metals, they lose electrons to form positive ions or cations. Okay, so we are testing for cations here. With an excess of aqueous sodium hydroxide. Okay, we are adding aqueous sodium hydroxide and excess aqueous ammonia. So when you add excess, immediately there's two things you have to note. Two observations are. One is the color of the precipitate. Second is the solubility in the reagent. Okay. So let's look at the observations. You have, when you add aqueous sodium hydroxide in excess, for number 1, you have colorless solution. Okay. Number 2, you have colorless, and number 3, you have a white precipitate. Okay, colorless solution, that tells us two things, right? One is either it is soluble in excess, okay, whether the precipitate is soluble in excess, or it can be no precipitate form, right? If there's no precipitate form, it will remain as a colorless solution. And if it's soluble in excess, it will also be a colorless solution if it's a white precipitate. Okay, white precipitate soluble in excess will give a colorless solution. So this tells us already that 1 and 2 is most likely a white precipitate soluble in excess. And for sodium hydroxide, right, there are two different types. Remember, Za will be soluble. Z is zinc, A is aluminium. So 1 and 2 can be either zinc or aluminium for now. Then number 3 is a white precipitate. So if it just says white precipitate, I already know that it's insoluble in excess. Okay, because you added excess equals, you added excess equals sodium hydroxide, but you still have a white precipitate. It shows that it's insoluble in excess. Okay, and there's only one white precipitate insoluble in excess, which is calcium. Okay, calcium ion, calcium hydroxide. So most likely 3 will be calcium. Okay, most likely 3 is calcium. So immediately I can eliminate a few options. If 3 is calcium, I can eliminate A and C. Okay. Then let's look at the second row. When you add aqueous, excess aqueous ammonia, what will happen? You have white precipitate for number 1, colorless solution for number 2, and colorless solution for number 3. Okay. So first thing I noticed, right, I have colorless solution for both for number 2 lah. That tells me one thing. It is both soluble in excess for sodium hydroxide and aqueous ammonia. And there's only one, right? Because remember what I said about solubility. When you add excess sodium hydroxide, Za will be soluble, like I wrote there. Then when you add excess aqueous ammonia, Zc will be soluble. Okay, so your zinc and copper. Then do you see the commonality between these two? Both have zinc, right? So since both number 2 is colorless solution, number 2 is definitely zinc. Okay. Then because this one is white precipitate, that means it's insoluble. Then you only have aluminium. Okay, so number 1 is aluminium, number 2 is zinc, and number 3 is calcium. Means your answer is B. All right. Are there any questions? If I'm going too fast, you can tell me to slow down or tell me to repeat the explanation. Okay, if there are no questions, can you give me a thumbs up? Okay, if not, let's move on to question 2. So I will send you guys all the inkings and the answer keys tomorrow lah. So you don't have to worry if you cannot copy finish. For question 2, most cations give precipitates with alkalis. Okay, hence the cation in a solution can be identified by using aqueous sodium hydroxide or aqueous ammonia. Explain why potassium ions cannot be identified using aqueous sodium hydroxide and aqueous ammonia. The thing about potassium ions, right? When they react with either sodium hydroxide or aqueous ammonia, what will it form? It will form potassium hydroxide. Okay. And if you remember your solubility table, right? Group 1 hydroxides are all soluble. Okay, group 1 hydroxide are soluble. And potassium is in group 1, right? If you look at the periodic table, potassium is here in group 1. Okay. So potassium hydroxide is soluble and therefore it won't be a precipitate, right? It will just dissolve in the aqueous sodium hydroxide or aqueous ammonia because it will react with it. So that's your answer. Because it won't form a precipitate. Okay. So potassium ions do not form precipitate with both aqueous sodium hydroxide and aqueous ammonia. And because potassium is in group 1 compounds or group 1 hydroxides, they are all soluble in water. Okay. So let you copy this down. So the only reason why we can test for cations, right, is because they have precipitate. Okay, then they have a color that we can use to identify. Okay. So we can actually observe. But if you just form a solution, you cannot observe anything, right? Because it's colorless. Yeah. That's why we cannot test for potassium ions. Okay, 30 more seconds, then I'll go through part B. Okay, part B. Maricite is a gray-white solid mineral that contains sodium iron 2 phosphate. Okay, so it is a complicated compound, sodium iron 2 phosphate, which is soluble in water. Describe a simple test to show that iron 2 ions and not copper 2 ions are present in an impure sample of maricite. Okay, so we know that maricite it contains iron 2 ions and doesn't contain copper 2 ions. So we have to do a test to prove it, right? And another keyword is this is an impure sample of maricite. That means we have to remove the impurities before we test for the iron 2 ions. Okay, we have to remove the impurities first, then we can test. So how do we remove the impurities? Over here it says that sodium iron 2 phosphate is soluble in water. Okay, so we can actually dissolve it. We add water to the maricite to dissolve the iron 2 sulfate, and then we filter it. Then from the filtration, we actually remove the insoluble impurities as the residue, and the filtrate will be your sodium iron 2 phosphate solution. Okay. Then from there, we can do our testing. So first we add water to the sample of the maricite and stir until no more dissolves. Okay. This is to ensure that we dissolve all the iron 2 phosphate, sodium iron 2 phosphate. And then we filter the mixture to remove the insoluble impurities. Then from there, we can start our test. Now that we remove the impurities, we add aqueous sodium hydroxide or aqueous ammonia to the filtrate. Okay, so you can use either aqueous sodium hydroxide or aqueous ammonia. And what will happen? How will you prove that iron 2 ions are present? There will be a green precipitate. Okay, green precipitate. Insoluble in excess will be formed. Okay, green precipitate insoluble in excess will be formed. This proves that there is presence of iron 2 ions. And the question also asks iron 2 ions and not copper 2 ions. So we have to say no blue precipitate will be formed. Okay. Okay, that is your copying. If you have any questions, do let me know via the chat or via WhatsApp. Can we use displacement reactions to show the ions? Displacement reactions to show the ions. Can you tell me how will you use displacement to show the ions? Because this is testing you on the test for cations. So how will you use displacement reactions to show the ions? How will you use displacement to show that iron 2 ions and not copper 2 ions are present? because I don't think we can use displacement. Yeah, it will be either you add equals sodium hydroxide or you add equals ammonia. Okay. Yeah, but that's a good question. Yeah, but I don't think you can use displacement to answer this question. All right. If not, we'll be moving on to the test for anions. Okay, so for cations, there are 7 cations to test. And for anions, there are 5 anions to test. Your nitrate, carbonate, chloride, iodide, and sulfate. Okay. So to confirm the identity of the anion after adding the reagents, there are different observations that you have to look out for different anions. So like for nitrate and carbonate, you test for the gas release. And then for chloride, iodide, and sulfate, you observe the color of the precipitation. So again, I have a memory shortcut for this. Naughty children get cane in school property. Okay, naughty children get cane in school property. So N will be nitrate, your nitrate ions. C will be carbonate. And then G basically means that you do a gas test. Okay. So for nitrates and carbonates, you want to test for the gas release. Okay. That means there'll be effervescence observed, and then you have to test for the gas. And then following that, naughty children get caned in school property. So C is chloride, iodide. School will be sulfate. And then property is precipitation. Precipitate. And that means you test for the precipitate. Okay. So by tomorrow, I'll send you guys all the memory shortcuts also. So if you didn't manage to copy down, I'll send you also. So don't worry. Okay. Which means for your chloride ions, iodide ions, and sulfate ions, right? You want to observe the color of precipitation. So firstly, you expect a precipitate to be formed, and then you have to observe the color of it. Okay, so let's go through the tests. For nitrates, you first add sodium hydroxide followed by aluminium foil. Okay, so 2 things are sodium hydroxide and aluminium foil. Then afterwards, you warm the solution. Okay, you warm it. So you allow the reaction to occur. And what will happen is ammonia will be formed. Okay, NH3 formed. Okay, remember for nitrates and carbonates, we will test for gas. The gas that we want to test here is ammonia. All right, so how do you test for ammonia? You use a damp red litmus paper and it will turn blue. Okay, so ammonia is an alkali gas. Ammonia is alkali gas. So it will turn a red litmus paper blue. Okay, and since ammonia is a gas, there will be effervescence observed as well. Right, so there are 2 observations. One is effervescence, second one is damp red litmus paper turns blue. Okay. Okay, secondly, carbonate. Okay, so again, carbonate, we have to test for gas. How do we test for carbonate? Add any acid. Okay, this one you don't really have to remember because this is actually learned in your acids and bases chapter. So if you guys attended my acids and bases crash course, right, I went through the acid reactions. One of it was acid plus carbonate. Okay, so acid plus carbonate will give you salt, water, and carbon dioxide. Okay, its main point is carbon dioxide. So carbon dioxide is the gas form that you want to test. Okay, so how do you test for carbon dioxide? Okay, so firstly you add any acid lah. So the acid will react with the carbonate ion, then will form the salt water and carbon dioxide. And to test for carbon dioxide, we use lime water to test for carbon dioxide. So if you didn't know, right, lime water is actually, it is very important. Lime water is actually calcium hydroxide. Okay, then calcium hydroxide reacts with carbon dioxide to form calcium carbonate, also known as the white precipitate. Okay, so we always learn that to test for carbon dioxide, bubble the gas into lime water and a white precipitate will be formed. But most of us don't know what is the white precipitate or what is lime water. So now I'm telling you, lime water is actually your calcium hydroxide, and the white precipitate is calcium carbonate. Okay. So carbon dioxide reacts with calcium hydroxide to form calcium carbonate. This is also your neutralization reaction, right? Calcium hydroxide plus carbon dioxide. Calcium hydroxide is an alkali, right? And then carbon dioxide is an acid. It's an acidic oxide. So acid plus alkali is your neutralization reaction. Okay, so everything is actually linked together in chemistry. Okay, where should I put this? Okay, I put this here. So for your observations, you will have effervescence observed because of the release of carbon dioxide gas. And then when you bubble the gas into lime water, a white precipitate is formed. Okay. All right. Next, we have chloride, iodide, and sulfate. So for these three, we'll be finding the precipitate color. Right. So for chloride and iodide, it's the same test. We'll first add dilute nitric acid followed by aqueous silver nitrate solution. Okay. So if you add dilute nitric acid followed by aqueous silver nitrate, for chloride, you'll form, to test for chloride ions, you'll form silver chloride. And then for iodide, you'll form silver iodide. Okay, then again, you link back to solubility table, right? All chlorides are soluble except for lead-2 chloride and silver chloride. Okay, so silver chloride is your insoluble salt, which also has a color, which is white. Okay, so your observations will be a white precipitate form, and that white precipitate is silver chloride. Okay, this is the ionic equation. Your silver ion plus chloride ion to give you silver chloride. And then for iodide, right, when you add dilute nitric acid followed by aqueous silver nitrate, you'll get silver iodide, which is yellow. Okay, it is also an insoluble salt. That's why it's a precipitate. So a yellow precipitate of silver iodide is formed. And this is the ionic equation. Silver ion plus iodide ion to give you silver iodide. Okay. So for these two, right, you observe the color of the precipitate. Okay. White precipitate for chloride and yellow precipitate for iodide. Okay, then finally we have sulfate, right? So for sulfate, we will try to make barium sulfate. Okay, because barium sulfate is an insoluble salt as well. That is white precipitate. So how to make barium sulfate? Add dilute nitric acid followed by aqueous barium nitrate. Okay, we're always using dilute nitric acid and barium nitrate, all the nitrates, right? Because all nitrates are soluble. Okay, that's why we use nitrates. And what will happen is barium sulfate is formed. So barium sulfate is formed, it is a white precipitate, and that will be the observation. Then your ionic equation is barium ion plus sulfate ion to give you barium sulfate. Okay, so for all precipitation reactions, right, your ionic equation is very easy. It will just be a breakdown of your precipitate. So since your precipitate here is barium sulfate, the breakdown will be barium and sulfate. So you just take these two out and put it at the left side of the equation, then you have your ionic equation. Okay, am I going too fast? Everyone okay? Right. If there are no questions, can I have you guys try question 3 and 4 and 5? Okay, 3, 4, and 5. I'll give your 6 minutes this time. All right, it's 8:49. I'll be going through the questions now. So question 3, a salt Q on warming with excess aqueous sodium hydroxide evolve a gas that turned then red litmus paper blue. So firstly, I see a gas that turned then red litmus paper blue. Immediately, I know it's ammonia. Okay, because ammonia is the only alkali gas that we learn in our syllabus. Okay, so it will turn then red litmus paper blue. And this salt reacts with aqueous sodium hydroxide to form this. Okay, which tells me that this salt contains NH4 plus, also known as your ammonium ion. Okay, because ammonium salts, they react with bases or alkalis like sodium hydroxide to form salt water and ammonia gas. Okay, so it tells me that this salt contains ammonium ion. Then next, when no more gas was evolved, aluminum powder was added and a further evolution of the same gas occurred. Okay, so after you add aluminum powder, more ammonia form. Okay, if you remember, right, this is actually your test for nitrates. So nitrates, you add sodium hydroxide, aqueous sodium hydroxide, followed by aluminum powder or aluminum foil, then you warm the solution, right? And what happens is ammonia gas is formed. So this actually proves that nitrate ion present. So what was salt Q? Very simple. You combine ammonium ion with your nitrate ion, you get ammonium nitrate. So your answer is D. Okay, answer is D. Any questions? Okay, then I move on to question 4. A crystalline product contains a mixture of two salts. One of the ions present is sodium. Okay, then a student tests the mixture to determine which other ions are present. So we have test number 1, which is you add dilute nitric acid, then add aqueous barium nitrate. Okay, so when you add dilute nitric acid, effervescence is produced, which gives white precipitate with lime water. So this gas that gives white precipitate in lime water is carbon dioxide. Okay, carbon dioxide. So this test is actually for carbonate lah, because when you add acids to your carbonate ions, you will form carbon dioxide, okay, which is your carbon dioxide gas. So this shows that carbonate ion is present. Okay. Then next, you add aqueous barium nitrate, a white precipitate is formed. When you add barium nitrate, right, your white precipitate form is barium sulfate, right? Because this is your test for sulfate. Okay. So I know that this white precipitate is barium sulfate, which means sulfate ions are present. Okay. So I found two ions that are present already. One is carbonate and one is sulfate. Then let's look at test number 2. Dissolve the mixture in water, then a blue solution is formed. What did we learn about blue solution? Forget family car, go right bicycle. So car and bicycle, car is copper, bicycle is blue. So your copper 2 plus ions are blue. Okay. So copper 2 ions are present. Then followed by adding aqueous ammonia drop by drop. A pale blue precipitate is formed that dissolves in excess ammonia to form a dark blue solution. This further confirms that copper 2 plus ions are present. Okay, because this is the exact observations you'll get when you add aqueous ammonia to a copper 2 compound. Okay, so we identified carbonate, sulfate, and copper 2. And then they also mentioned that one of the ions present is sodium. Okay, so let's see what is the answer. So first we have copper 2 carbonate and sodium sulfate. This is a possible answer. Next we have iron 2 sulfate, definitely out because there's no iron 2. Then C, we have sodium carbonate and copper 2 sulfate, also a possible answer. And then finally D, sodium carbonate and iron 2 sulfate. Again, there's no iron 2, so D is out. So it's between A and C. Okay, so how do we find the answer? If you read carefully, right, test number 2, it says dissolve the mixture in water. Okay, dissolve the mixture in water, then a blue solution is formed. What does this tell you? This tells me that both salts are soluble. Both salts are soluble. Okay, so I'm going to check whether all these salts are soluble. First, we have copper 2 carbonate, right? So for carbonates, only group 1 and ammonium carbonates are soluble. Is copper in group 1? No, copper is a transition metal. It is not in group 1. So this is insoluble. Okay, which means A is the wrong answer. Then if I check this one, right? Sodium carbonate and copper 2 sulfate. Sodium carbonate is soluble, yes, because sodium is from group 1. Then copper 2 sulfate is also soluble because all sulfates are soluble except for calcium, barium, and lead 2 sulfate. Okay, these are your insoluble sulfates, and copper is not one of them, right? So sodium carbonate and copper 2 sulfate, they are both soluble, which means C is your answer. Okay, so this is actually your TYS question. Right. Any questions for this? Question 4? Okay, if no questions, I'll move on to question 5. Some tests were carried out on a sample of river water. Fill in the table to suggest the expected observations and identities for the ions present. Okay, so test number 1, aqueous sodium hydroxide and aluminum powder were added to a sample of water and heated gently. Okay, so this one is testing for nitrate ion. Okay, the reason why I can deduce very fast, right, is because once you do more and more questions, you can just see the similarities in all the questions. Then you can deduce which cation or anion they are testing. Okay, so it's all about repetition. It's not just memorizing. Then observation is colorless pungent gas, which turned moist red litmus paper blue, was evolved. This is your ammonia gas, which is the correct observation if you are testing for nitrate. So the possible ion present is nitrate ion. Okay. Next test. Aqueous ammonia was added slowly to a sample of river until it was in excess. Okay, observation, quite precipitate form, which was insoluble in excess aqueous ammonia. Okay. So for aqueous ammonia test, remember I said only 2 things were soluble, right? Z and C. Only Z and C are soluble, zinc and copper. Okay, so it cannot be zinc, it cannot be copper, and it has to be a white precipitate. What are the white precipitates that are formed? White precipitates, we have zinc and aluminium, right? Calcium is not, because calcium, when it reacts with aqueous ammonia, there is no reaction. There is no precipitation. So zinc we already know is soluble. So aluminium will be insoluble, which means the possible ion present is aluminium ion. Okay. Then finally, aqueous silver nitrate was added to a sample of river water. And what is the observation? So we know the possible ion present is iodide ion, right? So if there's iodide ion, this means that silver iodide is formed, right? You add aqueous silver nitrate, silver iodide is formed. What is the color of silver iodide? It's a yellow precipitate. Okay, so your observation is yellow precipitate form. All right. Okay. So again, let me know if you have any questions. And if you have no questions, give me a thumbs up so that I know I can move on. Okay. Okay. So no questions. I'll move on to the final test, which is testing for gases. Okay. So unfortunately, I don't have a memory shortcut for this. Yeah. So we'll just have to remember lor. So we have 6 gases, okay? And then we can split them into 2. One is your pungent gases. The other one is your odorless gases. Okay, pungent means it has a very strong smell. Then odorless means you can't smell it at all. So first we have ammonia. Like we went through just now, it is an alkali gas, right? Alkali gas. Okay, so it will turn damn red litmus paper blue. So that's your test law. You put a damn red litmus paper where the gas is forming, and then it will turn blue. That's the observation. Okay. Next, we have sulfur dioxide, SO2. This is also a pungent gas. And this is a test that many people forget. Okay, so I urge you guys to remember this. SO2 is actually a reducing agent. Okay. So if you understand redox, you will know that in order for a reducing agent to oxidize, you will need what? You need an oxidizing agent. So you need a reducing agent and oxidizing agent in order for a redox reaction to occur. So in order to see the test for this gas, I will need an oxidizing agent. So usually we'll use acidified potassium manganate 7. Okay, KMNO4 in the chemical formula. And what's the observation? The observation is, of course, this oxidizing agent, KMNO4, it will reduce, right? Because SO2 is a reducing agent. So what is the color change when it reduces? It is purple to colorless. Okay, we learned this in redox. KMNO4 solution changes from purple to colorless when there is a presence of a reducing agent like sulfur dioxide gas. Okay, so I'm also giving the explanation for all these tests so that you can understand and you won't have to memorize. Right? Then next we have chlorine. It's another pungent gas. So chlorine is slightly different. Chlorine, right, it will actually bleach the litmus paper. So you can use either blue litmus paper or red litmus paper. What will happen first is if you use blue, right? Okay, wait, let me just put it here. Chlorine gas. Gas test. Okay, if you use blue litmus paper, it will turn to red, then it will bleach. Okay. If you use red litmus paper, it will just bleach immediately. Okay, so that's the procedure. That means overall it will just bleach lah. The litmus paper will bleach. That's the observation. Okay. Okay, then next, your three other odorless gases. So we start with carbon dioxide. So the testing reagent is lime water. So we bubble the gas into lime water. Okay, we don't add lime water to the gas because the gas is a gas, or it's in the air. So we cannot add lime water to the gas. We bubble the gas into lime water. Okay, so we bubble carbon dioxide into lime water. What will happen is a white precipitate is formed. Okay, so just a reminder, lime water is calcium hydroxide, and the white precipitate is calcium carbonate. Okay, so your calcium hydroxide reacts with carbon dioxide, alkali plus acid to give you a salt, which is calcium carbonate. Right. Then finally, hydrogen and oxygen, these two, they are quite similar, so don't get confused. Hydrogen, you'll use a lighted or burning splint, and then oxygen, you'll use a glowing splint. Okay, so both is splint, but it's different now. So for hydrogen, there will be a pop sound extinguished when you put a lighted splint at the mouth of the test tube or where hydrogen is formed. Then for oxygen, the glowing splint will relight. Okay, that means you'll see it relight again. That's the observation. So there's two different observations for this. Right? So in total, there are 6 gases for you to test. Okay, so in total, 7 cations, 5 anions, and 6 gases. And I gave you a few memory shortcuts, so that's easier to remember. Okay. Right. If there are no questions, I just have one question for you to try, which is this one, question 6. So I give you 2 minutes. Okay, that was a quick 2 minutes. So the following substances are used in the laboratory to test for various ions and gases. Okay, various ions and gases. So we have 9 different substances here. When testing for ammonia, chlorine, hydrogen, and oxygen, what is the minimum number of items from the table above needed to identify these 4 gases? Ammonia, chlorine, hydrogen, and oxygen. So we have to figure out what is the reagents we have to use lah. For ammonia, it's a red litmus paper. Oops. For chlorine, it is just any litmus paper. Okay. For hydrogen is, wait, let me just erase any. Hydrogen is a lighted splint. And oxygen is glowing splint. Okay, so these are the apparatus that you need, or the reagents that you need to test for the gases. Right? So what's the minimum number of items? If we look at ammonia and chlorine, ammonia is red litmus and chlorine is any litmus paper. So for ammonia and chlorine, we can use a red litmus paper for both. Okay, for ammonia and chlorine. And then look at hydrogen and oxygen. One is lighted splint, the other one is a glowing splint, right? So both is a type of splint. So we can use a wooden splint for both. Okay, for both hydrogen and oxygen. Okay, so in total, you only need 2 items, which means your answer is 8. Okay, if not, I think we might not have enough time to complete to go through these extra practice questions. So I tell you what, by tomorrow, right, I'll send the answer keys of these two questions. So I want you guys to attempt these questions if you haven't already. And you all can check with the answer key tomorrow when I send you guys. And then when you refer to the answer key, if there's any question where you don't understand the reason why that is the answer, you can just send me a WhatsApp text. Okay, then I'll try to explain. Right. So question 7 and 8, I'll send the answer key to you guys tomorrow. Okay, in the Telegram chat. Okay, if not, we'll be moving on to the Kahoot quiz soon. So before that, I just want to let the Sec 3s know. If you are Sec 3 currently, we currently open 5 more spots for October. Okay, and there are 3 spots left. And those who sign up for the first month, right, you'll get a 10% off. Okay. So if you're interested for weekly tuition classes, you can sign up tinyurl.com/signuplch. And then our classes are on Sundays, 3 to 5 p.m. Okay, all our lessons are recorded and you'll get infinite WhatsApp support. That means any questions you have, you can just WhatsApp me. And just for signing up, we'll send you a full compilation of our crash courses. Okay, so Sec3s, if you're interested, you can sign up via this link. Right, if not, can you guys go to this link here, www.kahoot.it, and we will begin our Kahoot quiz. Okay, we can begin now. So there are 10 questions in total. What color precipitate is formed when copper 2 sulfate reacts with sodium hydroxide? Okay, all of you got it correct. Good job. Okay. When aqueous ammonia is added to an unknown solution, a pale green precipitate forms. What cation is present? Okay, most of you got it correct. So it's iron 2 plus. Okay, good job, SY. Which cation forms a white precipitate in aqueous ammonia, which dissolves in excess to give a colorless solution? So white precipitate with aqueous ammonia and dissolves in excess will be zinc. All right. Okay, so which test is used to confirm the presence of sulfate ions? Sulfate ions, we add dilute nitric acid, then we add aqueous barium nitrate to form barium sulfate. Okay, and that is a white precipitate. Okay, Jean is catching up. Which anion forms a yellow precipitate with silver nitrate? Well, you guys answer very fast. Iodide, yes, most of you got it correct. So silver iodide is your yellow precipitate. Okay. SY still in the lead. Which anion, when tested correctly, will have observations of effervescence? Yeah, answer is carbonate. So remember the memory shortcut. Naughty children get cane. Okay, so N, C, and G. N and C will be your test for your gas. Okay, N is nitrate, C is carbonate. So carbonate is your answer because there's no nitrate here. Oh, Jean is now in the lead and Nico has caught up. Which gas turns damp red litmus paper blue? Okay, simple question. Ammonia gas is an alkali gas, so it will turn damp red litmus paper blue. Oh, Keston is catching up. What observation confirms the presence of chlorine gas? Good job, everybody got it correct. Okay, question 9. Lighted splint test. Okay, so when metal reacts with dilute hydrochloric acid, hydrogen is formed, right? So to test for hydrogen, we use a lighted splint. And what confirms the test is the pop sound, right? Pop sound will be extinguished. Nicole is now in first place. Good job. In which reaction is a white precipitate formed? It is a long question. I give you all 45 seconds. I hope you guys can get this correct because I explained this one like 2 times. Okay, so why is the answer yellow? Aqueous calcium hydroxide plus carbon dioxide. So aqueous calcium hydroxide is actually lime water and carbon dioxide is your gas. So when you bubble carbon dioxide into lime water, a white precipitate will be formed. Okay, that white precipitate is calcium carbonate, right? So this is actually your neutralization reaction. Carbon dioxide is an acidic gas, then calcium hydroxide is an alkali. So acid plus alkali is your neutralization. You get salt and water. Okay, and calcium carbonate will be your white precipitate. Right, in third place we have Advaita. Good job. Second place, Jean. And first place, Nicole. Right, good job, everybody. Okay. So I'm going to share my screen back. Okay, before you do the feedback form, I want to go through the last question. Okay, where should I go through? Okay, let me create one more empty page. Okay. So just now we have calcium hydroxide plus carbon dioxide to give you calcium carbonate. Okay, this is the reaction. Calcium hydroxide plus carbon dioxide to give you calcium carbonate plus water. So calcium hydroxide is your lime water. Okay, so I want you guys to note this down because this is very important. Calcium hydroxide is lime water. Then carbon dioxide is the gas that you're testing. Calcium carbonate is your white precipitate. And then water is just another product. Okay, so this is your neutralization reaction. So neutralization is acid plus base, right? Acid plus base or alkali. So your alkali in this case is calcium hydroxide. Okay, because an alkali dissociates in water or ionizes in water to form hydroxide ions. Then your acid is carbon dioxide. So remember your types of oxides, right? Carbon dioxide is your acidic oxide. Okay. So this is why this is a neutralization reaction. Okay. So if there are no questions, those who first time come here, can you scan this QR code and fill up the feedback form? I would really appreciate it. Okay. And then just let me know if you have any questions while I wait. Okay, so how do you guys find the crash course today? Was it helpful or beneficial to you guys? Okay, I got 1 thumbs up, 2 thumbs up. All right, nice. I hope I cleared up all your misconceptions on qualitative analysis. Okay, and then again, the answer keys and my inkings, I'll send it tomorrow in the Telegram chat. Yeah, so my tips for you guys, right, for qualitative analysis is don't just focus on memorizing the test for everything. Try to understand the reason why. Okay, for some you have to memorize, but for other tests like tests for carbon dioxide, we can understand the reason why we use lime water, right? Because it reacts with carbon dioxide to form calcium carbonate, which is a white precipitate. Okay, so try to understand and try to do more questions. Then it will familiarize you with different question types, and then you won't be scared in the exam, right? Because one of the question type might just come out and you'll do well. Okay, so whether you're Sec 3 or Sec 4, you'll do well if you do more questions. Okay, then for those who finish filling up the feedback form, we can end off early today. You all can leave already. Right, thank you everyone for coming today. Right, I'll be ending the call now.